This video covers section 11.3, Logarithmic Functions. Objective 1, change exponential equations to logarithmic equations. Logarithmic functions arise from when finding the inverse of an exponential function. We've seen these exponential functions f of x equals a to the x. We remember that a is never 1 and a is greater than 0. We want to find the inverse of an exponential function, just like we have always known that the inverse of addition is subtraction, the inverse of multiplication is division, the inverse of squaring is square rooting. We need to be able to invert the exponentials. We do this by the switch and solve. Remember, we start off by putting the y back into the problem. We form the inverse by swapping the variables. Now this equation defines for us our inverse problem. However, we need to be able to solve for y to say what the inverse function is. So someone came along with, let's call this the logarithmic function to the base a, where a is the same restrictions as before. It's denoted as y equals log base a of x, or read, y is the logarithm to the base a of x. And the equivalencies between these two statements is what we use to change exponential to logarithmic and logarithmic back to exponential. This is by far the most important piece out of this handout. If you have something in the logarithmic form, we can convert back and forth using these equivalencies. Y is equal to the log, and y is always the exponent on the base. So the base here is 10, and the exponent is 2, or 10 squared is 100. Whereas 5 equals log base 2 of 32, 5 is the exponent. The base is 2. So that says 2 raised to the 5th power is 32. Going the other way, we see our exponential expression is given, and the exponent is -2. The logarithm always equals the exponent. The base is 4. The a or the base is 4, so that's log base 4 of 1/16. So notice here how the log always equals the exponent. We must always remember that a logarithm is an exponent. So how do we change back and forth then? Practice 1. Rewrite each exponential equation as an equivalent logarithmic equation. So we have the two statements that x equals a to the y is equivalent to y equals log base a of x. The y is the exponent, and it always equals the log. We're taking exponential and writing into log form. The exponent is 3. The base is 7. And the number is 343. So we say log base 7 of 343 equals 3. To write x squared equals 9 in logarithmic form, we always start off with the exponent because the logarithm equals the exponent. Base x to get 9. 4 to the 5th equals y. The log equals the exponent of 5, base 4 of y. So all of these are started by locating the exponent and setting it equal to the log, and then finding the base and then the number. In the next video, we'll cover how to go the other way, changing logarithmic back to exponential. And this concludes the video for section 11.3, logarithmic functions. Objective 1, change exponential equations to logarithmic equations.